Cause we've done this before, so you come on in. Make yourself at my home, tell me where you been. Yourself something cold, baby, cheers to this. Sometimes you gotta stay in, and you know where I live. Yeah, you know what we is. Sometimes you gotta stay in. Welcome to my house, baby.
Hi everyone, this is Tan. So in the previous ISU physics essay, we talk about quantum mechanics, speed of light, and the Large Hadron Collider. What is quantum? Well, long time ago, a German scientist, Max Planck, came up with an idea how to make a light bulb more efficient. Given the light bulb's more efficient energy, it's just like imagine you have to feed infinity keys with iPad. Well, feeding all infinity keys with a single iPad, or maybe you have to buy a lot of iPads, it seems impossible. But Max Planck came up with an idea with quanta. So after a while, Max Planck worked with Albert Einstein, which is one of the craziest scientists we ever knew, and they finds out quanta. Quanta is a package of energy that could be feed all light bulbs, just like feeding iPads with infinity keys, but light bulbs is more possible. Oh, so if Max Planck and Albert Einstein going to feed 1 over infinity of energy to all light bulbs, is kind of small, but it's possible because waves have different types of wave, from bigger to smaller to infinity small. So, just a quick explanation to the bulb. Let's look at this bulb. This light bulb, in daily life, there's a lot of frequency from smaller to even smaller, and smaller and even smaller but high in frequency, and the smallest one. Well, in the feeding keys with iPad examples, you can't give all infinity keys every single of them at iPad, but you could give every light bulb or even single light bulb a very low frequency, but I can give a small wave but high in frequency, just like this. And every high frequency but low in wave length will consumed by the light bulb, and the light bulb will never gonna worry about low energy situations anymore. So right now, the light bulb will consume more energy in a more efficient way. Quantum particle explained that every particle in the periodic table will change its shape due to vacuum. Let's just say hydrogen. When hydrogen moves from sun to the deep space in the universe, the shape of the hydrogen particle will change due to the situation and properties of himself. When the hydrogen particle changes its shape, it will happen to three-dimensional situations, which is the x direction and the y direction. Of course, as well as z direction. A lot of scientists and physicists use the theory of quantum mechanics to invent a lot of tools and technologies to prove speed of light and even particles, subatomic level, atomic levels of technologies, tons of physics and chemistry, sciences. The theory of quantum mechanics leads to many scientists discover a lot of technologies, tools, and devices. Speed of light is one of the technologies they use in Large Hadron Collider to push particle to the speed of light, to the level of speed of light, can make the particle change or form and makes diffusion and fission to make new particles.
The Large Hadron Collider is the world's largest and most powerful particle collider. It is the largest and most complex experimental facility ever built, and it's the largest single machine in the world. Colliders are used as a research tool. They accelerate particles into very high kinetic energies and let them impact other particles. Analysis of the byproducts of these collisions gives scientists a good evidence of the structure of the subatomic world and the laws of nature governing it. It was built by CERN, the European Organization for Nuclear Research. It was built from 1998 to 2008 in collaboration with over 10,000 engineers and scientists from over 100 countries, as well as universities and laboratories. It lies in a tunnel 27 kilometers in circumference, as deep as 175 meters. It lies beneath the France-Switzerland border next to Geneva. The aim of the Large Hadron Collider is to test the predictions of particle physics, high-energy physics, and furthermore, test the properties of the Higgs boson. The Large Hadron Collider has 7 detectors. Each are used for a different kind of research. The proton-proton collisions are the main testing method, but the LHC also in 2013 has collided protons with lead nuclei, and lead-to-lead collisions have been used for further different types of investigation. Many of these byproducts are produced by high-energy collisions, and they decay after a very short period of time. Therefore, it is nearly impossible to study them in other ways. Physicists hope that the LHC is going to help us understand and answer some of the fundamental and basic questions in physics concerning the interaction between elementary objects, the structure of space and time, and the interrelation between quantum mechanics and general relativity.
In a theory of speed of light, I explained that if an object can move to the level of speed of light, the state and the environment will change as well as the time. What I'm saying is, if let's say I'm moving at the speed of light in vacuum, which is space, my time will be changed. It's either slow or fast relative to the person on Earth or Moon. My distance might be changed according to many theories from scientists and physicists like Stephen Hawking, Albert Einstein, and many. When we talk about speed of light, we could include a little bit of the general relativity from Einstein. When an object moving at the speed of light in the universe on different planets, relative to another person who described or observed the object, the speed, the time, and the distance for both of them will be different completely.
Open up the champagne, pop. It's my house, come on, turn it up. Hear a knock on the door and the night begins. Cause we've done this before, so you come on in. Make yourself at my home, tell me where you been. Pour yourself something cold, baby, cheers to this. Sometimes you gotta stay in, and you know where I live. Yeah, you know what we is. Sometimes you gotta stay in. Welcome to my house, baby, take control now. past, let's pretend that the time has changed. Keep our clothes on the floor, open up champagne. Let's continue tonight, come on, celebrate. That's how we do. Sometimes you gotta stay in, and you know where I live. Yeah, you know what we is. Sometimes you gotta stay in. Welcome to my